when you are dealing with, rotation, you have to tell me clockwise or counterclockwise, you have to tell me the angle of rotation, and then you also have to tell me where the center of rotation is, those three things. We'll talk about how you can figure out the angle if it's not obvious. This angle's obvious because it creates a 45-degree angle here, because each quadrant is how many degrees? How many? 90. So if I split in half, I got 45, okay? This one is a little trickier. I know that it includes this whole 90-degree angle, and then I would figure out this portion and this portion. That's how they get to 20. But we can talk about that later. Okay, now, they want to know about these three images here. Tell whether the transformation is a rotation about the origin. If so, give the angle and the direction of rotation. So, if I go from blue to red here, would this be rotation? Can I rotate it up that way? For it to stand like that?
Yes.
Okay, and where would the center of rotation be in that case? 0, 0. 0, 0 is my center of rotation, if that's rotatable. And what degrees do you think that would be rotated? Take a guess.
90?
Possibly 90, and which way?
Clockwise?
You think clockwise? Okay.
Yeah.
You think clockwise? Good, yeah. So it's 90 degrees clockwise rotation, and it's 0, 0 is the origin. Good, perfect. Because if I rotate 90 degrees, it's gonna stand straight up and down. Yes, Carter.
If we have that problem in our homework, do we just guess the degrees, or will they give us like a formula?
Well, do you know why he said it's 90?
Well,
Because if you go and look like this, from here to here, okay, if I draw a straight line from there to there, and draw a straight line from there to there, what type of angle does it create?
Well, I can't really see.
It creates a 90-degree angle, okay? Creates a right angle. That's how you figure out your angle of rotation. You draw a line from, you're gonna have to use a straight edge tonight a lot. So you're gonna draw a line from the center of rotation out to the point, and then from the center of rotation out to the new point, and then you have to measure that angle. Now, you can measure that angle one of two ways. So, if I have a line like this, okay, what I'm going to do is take one of these. What is this? Protractor. I'm gonna take a protractor, and I'm going to line up this center spot. Do you see that like little circle spot down there? I'm gonna line up that center spot dead on the center of those lines I made, okay? If I do that, I can figure out what type of angle measurement it is. Or I can line it up like this. It's actually easier to do it this way. And I line up that center spot still right there in the dead center, but I create one of these lines to be even. Does that make sense? And from here opening up to here opening up, this is about 75 degrees. So that's a 75-degree angle. And you can read it that way to get it more accurate. But you're going to have to draw straight lines. I'm going to need to see those. And then you're going to have to take out a protractor and measure it. Okay? That's the easiest way to do it. Part B, does this have rotational symmetry from the blue to the red? You have to try to visualize some of this stuff. This stuff's a little bit more difficult because we have to see it in our heads. So if I flip this blue, let's say I went this way, just for the heck of it. What way would this blue end up when I rotate it 90 degrees that way?
On the
No,
others.
you can't do that.
It would take this and this short side would go over here, right?
Yeah, and then the long side.
And then the long side would be over here, correct? And then it'd be like this, yes? Okay, and then if I rotate that down 90 degrees, would it end up on there?
No,
No.
No. So is it rotational symmetry?
no.
No. Okay? So that's a way that you can start to visualize it. Graph it into the next segment, graph it into the next segment after that. Okay? So not rotational symmetry in that case. What about this blue triangle to the red triangle? So if I go blue triangle, and let's say I go up to this quadrant, if I rotate it 90 degrees, what does that mean about that blue triangle? How does that flip?
The long side.
Well, what side ends up where? Where's the short side end up?
Or not.
If you flip it to
On
axis,
Yeah.
it's going.
It doesn't matter which way we go. So if I go this way, okay, and I flip it this way. So I do that.
The triangular side's gonna be where the arrow is. Okay.
It will be where the arrow is, but you have to think, can I rotate it from here to here to here? So that it lands in that position. Emma, you say yes? Okay, what type of rotation would that be if that's true?
180.
180. Can I go from here to here to here? Yes, and it's still 180. So technically, this has rotational symmetry of 180 degrees in either direction. So either way is correct, okay? Now, 90-degree rotations. We're going to give you a cheat sheet for this, okay? This makes it easier mentally, okay? In this book, all rotations in the coordinate plane are centered at the origin. So when you're dealing with this textbook, we're not doing anything more difficult than it's centered at the origin. Every rotation's about the origin, okay? About 0, 0. You can use coordinate notation to describe a 90-degree clockwise rotation. So if A, 2, 3, 3, 1 rotates 90 degrees down here, I get 3, -2, and 1, -3. What do you recognize about those new points? Okay, what, E?
They just look, but the y is
Yes.
negative.
They're flipped, but this part became negative, yes? Okay, so the formula for that, remember how we talked about coordinate notation and formulas? The formula for that coordinate notation, 90 degrees clockwise, okay? And then this way you don't have to visualize it, you can just do it, is this. Y and X switch places and X becomes opposite of what it was. Okay? So your formula is, if you have XY, it becomes Y negative X. Okay? So if I had negative XY, it would become Y positive X. Does that make sense? Okay? If it's 90 degrees counterclockwise, okay, so really the only thing you have to be able to recognize is if something is counterclockwise or if it's just clockwise, okay? Hopefully you can do that. If it's counterclockwise, it goes from XY to the opposite of Y, X. The Y becomes negative instead of the X, okay? So as you can see on this one here, blue is original 2, 3, 3, 1. This became -1, 3 and -3, 2. X and Y still switched, okay? But Y became negative instead of the X when it's counterclockwise. When it's clockwise, X becomes negative. Okay? So then we get to this problem here, and I'm not going to raise it up any higher, but I'll read it and we'll do it together. It says, draw a triangle ABC with the vertices of -3, 4. So we're gonna okay. So it wants -3, 4 for A, -3, +4 A. For B, it wants -2, 3, -2, 3. And for C, it wants -2, 1. Okay? And it wants me to find the coordinate of the vertices of the image after a 90-degree clockwise rotation, then draw the image. So, what would be the new coordinates for this if I'm going clockwise 90 degrees? Carter? What would A be?
A would be 4 +3.
for +3.
B would be, is that, I think
It says -2, 3.
So, yeah, -3, -2.
No,
No.
Oh, wait, no.
what would B be?
Wait,
+3, +2.
Yeah, +3, +2. X and Y switch, X becomes opposite of what it is. And what would C be? It's -2, 1 right now.
+1, +2.
Yeah, +1, +2. So if I graph those, 4, 3, that becomes my mapped A. And I graph 3, 2, that becomes my mapped B. And if I graph 1, 2, 1, 2, that becomes my mapped C. And I have, if I had real graph paper, it would actually look right, but you know. So those are my new points. Okay, here's what it really looks like, because I don't have real graph paper. 4, 3, 3, 2, 1, 2, okay? Which is exactly the points we got.
I got a
Okay.
question.
4, 3, 3, 2, 1, 2, and that's how you graph it. What?
Wasn't it supposed to go to a negative? This is clockwise.
No,
But
it's
if it's
supposed to go opposite. That negative sign means that it's gonna be opposite of what it was. So if it's negative, it turns to positive, the X, and if the X is positive, it turns to negative. It'd be like putting a double negative there, okay? Because this says -3, it's like -3, which gives you a positive. Okay, and that's what we're looking at there. Now, 180-degree rotation. There's a cheat sheet for that too, okay? If you have 180-degree rotation, which doesn't matter which way you're going, clockwise or counterclockwise at that point, right? I can go clockwise 180 and I go counterclockwise 180, I land in the same spot. So 180-degree rotation yields this formula. If you have the points x, y, you're going to get the opposite of x, the opposite of y. So if I had -x, -y, I get +x, +y. If I have +x, +y, I get -x, -y. If I have -x, +y, I get +x, -y. It's the opposite of what they are, okay? So on this, it shows you over here, you have 1, 3, 2, 1, which means I get, for point B, -2, -1, and for point A, -1, -3. It rotated down this way and then over, or it rotated this way and then over. It doesn't matter, 180 degrees is just 180 degrees, okay? There's no way around that. There's nothing special that we can do. Now, there's like 2 more, or just 1 more thing, I think. So, it says, let's draw this triangle, and then we're going to rotate all of these degrees. And once again, I'll show you the picture at the end because it will be better than mine. Okay, so let's say we're drawing, what is it? M is 1, -2. 1, -2. And N is 4, 1. I just scrapped that wrong, didn't I?
Yeah.
Yes, because I'm being silly. 1, -2. And N is 4, 1. 4, -1? Yes. 4, -1.
P is 2, -2.
And P is 2, -3. 2, -3. Oh, it's like down here in my, where I wrote. Okay, so this is my triangle. Now they want us to map it, okay, after a 180-degree rotation. So what does point M become? What does mapped M become? It's 1, -2 right now.
It'd be -1,
Two,
+2.
It would be -1, +2. You don't switch them on this, you just switch the signs. What does mapped N become?
Negative
-4,
4.
+1.
Yeah. And what does mapped
Negative
P become?
2, +3.
Beautiful, and so then it would look like this. Okay? So we got -1, +2, -4, +1, and -2, +3, and that's what those 2 images look like. On your homework again tonight, if you don't have separate colors to use, you have to put those tick marks. Even if you have separate colors to use, put the tick marks, so I know which one's which. Okay, show me your work, like that I went from this point to this point, just show me what yields what. The last thing you need to know, a figure has rotational symmetry if a rotation of 180 degrees or less clockwise or counterclockwise about its center produces an image that fits exactly on the original figure. Meaning this, if I take a square, okay, if I have a square as a shape, and I rotate that, okay, pretend it's in this quadrant, if I rotate that down here 90 degrees, does it map back to a square? Yes.
Yeah.
Okay, so that has rotational symmetry because it maps back onto itself. As long as it maps back onto itself by 180 degrees, you have rotational symmetry. If it doesn't map back onto itself, where I could lay it on top of itself and it be the same thing, then it does not have rotational symmetry. So, the family crest shown on page 741, which we looked at earlier, has rotational symmetry for 90 degrees or 180 degrees clockwise or counterclockwise. Here's why. Do you see how this is a circle? And then this shape has symmetry within itself, yes? Right here? Okay, so if I rotate it 90 degrees, A ends up down here, D up there, B and C, yes? Do you see how that works? It's still the same object, right? Like I can lay it on top of itself and it's the same thing. Okay. So that shows that it has 90-degree clockwise rotation. If I go the other way and rotate it this way, A ends up over here, B up there, but it's still the same image on top of itself. So it has 90-degree counterclockwise rotation. It also has 180-degree rotation because if A was originally there and I move it all the way to here, it's still the same shape and object. So it has 180-degree rotation. Okay? So that's what we're looking at when we talk about rotational symmetry, okay? And then you're going to get questions like this on your homework where you're going to be asked if that has rotational symmetry. My suggestion is this. Take a pencil in your book and erase it afterwards, but lightly draw a grid, okay? That breaks it into 4 quadrants so that you can visualize turning it and seeing if it would end up on itself. Because if I draw a grid like this through this one, okay? Will that have rotational symmetry?
No.
Well, if I rotate it 90 degrees, it's not, right? But if I rotate it 180, does it map back onto itself? Yes. So that has rotational symmetry at 180 degrees. Okay? So that's what I mean by take a look at it, because it should help you a little bit more. Okay? This is very visual and can get a little bit tricky sometimes.